Good morning, good afternoon, everybody, and welcome to the first in a series of 4 webinars we're doing on the private LTE market environment opportunity, however you look at it. Today, we'll be talking about deploying a private network solution using LTE, 5G, edge compute, and of course, CBRS. I think during today, we're going to hit all of those points. But before we get into the content, I've got a little bit of housekeeping. Firstly, my name is Ian Gillett from IGR. I'll be acting as the moderator today. The webinar today is brought to you by the 2030 Project, which is a partnership actually between IGR and Smart Gig Media. So think of 2030 Project as the producer, think of IGR as the content and pulling it all together. I've got 3 great speakers today I'm going to introduce to you in a minute. Firstly, this session is being recorded. The recording will be available in about 24 hours. We'll send you an email with details on how to access that, and also the slides as well, okay? So don't have to try and write everything down. We are taking questions today. I have to say we had a lot of people register for this webinar, and I think nearly all of you submitted questions when you registered. We did download those and I sent them to the panelists. So we will try and address them as we go through. Some of them we're going to address in future webinars. The next webinar we have is actually on applications and services for private LTE. So some things we're not going to dive in too deeply today. Other things we are, namely deployment and how you actually build the network. If you have questions today, just use the questions tab on the GoToWebinar control panel there, and we'll either take them as we go through, or we'll address them at the end. We'll have some time at the end as well. We are going to finish about 50 minutes past the hour today. We want to try and get through this, make it succinct, make it applicable, and go from there. All right. So with that, let's see here. Okay. So the speakers, myself. Obviously, I'm moderating. Cradlepoint, we have Ken Hosak, who's VP of IoT Strategy and Business Development. He is the one with the Cradlepoint logo on his shirt up in Boise, Idaho. Gary Wood is the only guy wearing a jacket here, and he's Vice President of Intelligent Edge for Pivot Technology Services, and Gary is in Omaha, Nebraska. And John Merchant is Senior Director of Portfolio Management for 5G and IoT for Cineverse. And even though Cineverse is based in Tampa, John is in Colorado, Denver, right? Yes. So we're all over the place today. As I said, we will be taking questions, so just let us know as we go through. Now, what we're going to do today is rather than just have each presenter speak in turn, I've got some questions for them. We're going to step through and have everybody participate at different times. We've got a bunch of slides I'm going to let them talk to. So firstly, we're going to talk about what is a private network. We can talk about the components that are needed to put that network together. So some application integration, you need SIM cards, you need a packet core, the Evolve packet core, you need some devices and routers, of course, and edge compute comes into this as well for the applications. We'll talk about all of those as we go through. We're going to touch on licensed versus unlicensed spectrum. It's a big subject within private networking. We will talk briefly about some use cases. We're not going to dive into huge detail. That's the subject of the next webinar in 2 weeks' time. We will talk about how you move to 5G from LTE. We'll talk about where the edge is, and then we'll wrap it up and take questions. I did just put a box up here as well. The first one is Private LTE for Enterprise. That's actually our website where you can get a lot of resources on private LTE. We'll have the webinar up there and the slides and all those things. Also, of course, you can go to Cradlepoint, Pivot, and Cineverse. All 3 of those companies have got a lot of resources on there. One thing I would note is that Pivot is with 2 T's and an S because it's Pivot Technical Services. I've made the mistake of Pivot without the extra T and the S, so it doesn't work. So, all right, so with that, let's get into it. And the first question, I'm going to hand off to Ken here. So really easy, Ken. 60 seconds. Who is Cradlepoint and what do you guys do?
Hey, thanks for having us in here. Cradlepoint is the worldwide leader in helping enterprises leverage wireless as an enterprise WAN, as an internet connection. And so our customers include enterprises with fixed locations, and these could be branch offices or retail stores or quick serve restaurants that are either using wireless as primary or in some cases in an SD-WAN type environment along with cable or DSL. Our second segment is in the mobile segment. These are primarily vehicles. A lot of first responders, whether it's police or fire trucks, buses, whether it's public transit or school buses, pop-up facilities. And then our IoT machines, kind of machine segment, is a lot of kiosks, digital signage, smart city applications, et cetera. But our solution is a cloud-delivered software-defined solution that really makes it easy for them to use wireless, which today is 4G LTE. We're launching 5G, and we're going to talk today about private LTE.
Right. Okay, great. And I know the audience had a lot of questions for you. We had a lot of questions like, I've got 500 connections. How many Cradlepoint routers do I need? And so we'll get a little bit more detail that you guys do later on.
Yep.
Okay, Cineverse, John Merchant, same question. 60 seconds. Who are you? What do you guys do? And you've got the most colorful slide. You win.
Thanks. So Cineverse is, we like to call ourselves the most connected company in the world. We provide roaming and ancillary services for mobile operators and mobile devices. We connect 700 mobile operators around the world and 7 billion mobile devices that are customers of those operators. Importantly, though, we're also providing the financial clearing and settlement. So not just the connectivity, but also we facilitate the business models that enable roaming from one network to another. And we also clear out the mobile messaging between these operators as well, delivering over 60 billion messages every month. And while we focus traditionally on the public mobile network operator space, we are taking these services into the private space as well to provide that same seamless coverage to private devices around the world.
Okay, great. And we're going to touch with you later on the packet core, SIM management, and all those good things as well. All right. Gary Wood, the guy in the jacket. Who are you? What does Pivot do?
All flash, no substance, Ian. That's what it is. Yeah, delighted to be here today, and especially with John and Ken, who represent a couple of companies that are important partners in our private LTE ecosystem. So Pivot is both an SI and a VAR. We are a customer base of over 1,600 enterprise, public sector, and service provider customers. We are a network of 8,000 field resources in North America for deployment and post-sale support. We are an ecosystem of over 800 technology suppliers that we connect with those customers and leveraging those resources that we have out in the field. In private LTE specifically, we also have another element or dimension to Pivot that's really germane to and relevant to the private LTE discussion. And we'll talk about that a little bit later, but it is fundamentally a partnership that we have with Intel around multi-access edge compute, or MEC, which is a foundational piece of private LTE. So we are an exclusive provider of the Intel Smart Edge MEC solution, and that's also an important building block here. So that's kind of where we sit in the value chain of private LTE.
Okay, and I know you're in Omaha. Where's Pivot based?
Pivot is headquartered in Norcross, Georgia. Okay. And we are widely dispersed throughout North America in terms of our field presence, sales, and field offices.
All right, great. Okay, so I'm going to take just a couple of slides here to kind of set the picture here. This is a slide I've used before. It took me, I built it a year or so ago, and it took me, I built it over the holiday. But basically, this is the world as we kind of see it in a few years' time, 5 to 10 years. Everything is 5G. And you can see on either end, we've got macro cells here with 5G. And then we've got areas of high density, high capacity networks, probably obviously with some small cells, could be running millimeter wave. And that's really the yellow areas. And we're not going to go through all of these, but you can see we've got Class A commercial space, manufacturing, transportation, stadiums. The one I particularly like is the hospital on the top, and then the emergency services on the bottom there. And of course, vehicles running around, either autonomous vehicles running around a manufacturing facility, drones going around a stadium for video, drones outside a building looking for damage or for maintenance items, things like this. So this is kind of the world when everything's connected. It's IoT, it's people, it's workplace, it's home. And the question we often get is, well, where does private LTE fit? And so if you look at these green areas, you could be a manufacturing plant, for example, and want to have a private network there just for use within the facility. Maybe it's got some security cameras, or it could have some connections to tools, manufacturing tools, the autonomous vehicles running around. It could be a warehouse, distribution center, something like this. In commercial spaces, you could have a dedicated LTE network just for the tenants. So they've always got capacity, they've got coverage throughout the building from the top to the bottom. Within the stadium, actually, this is one of the most interesting ones, is private LTE has already been deployed using CBRS, which we'll talk about, within a stadium, separate from the Wi-Fi. And the reason they've done that is for point of sale. So they're able to swipe credit cards and get the capacity and the connection they need. Other times they were finding they didn't have the capacity to actually swipe a credit card. And of course, that means fewer sales per hour, the lines get longer, etc. The other one, of course, it could be in a hospital, but also down the bottom there, you'll see there's a house on fire next to emergency services. We could have a temporary private LTE network set up for emergency services. It could be used by emergency management, fire, whatever, police, whatever's needed. It could be for a specific event. It could be every weekend. So this is how to think about private network. The biggest question we always get is, what's the best application? And the answer is there's a very long list of things that it works very well for. And really, you're limited almost by your imagination. So this is what we're going to talk about today. We're going to talk about how you build these green blobs, these private LTE networks. So the first question I'm going to hand over to Ken here, and really, starting at the top, Ken, we've got those green circles now. What are the components you need to actually build that network, and how does it all fit together?
Yeah, thanks. The top, I would say, is the cloud elements. The mid part is the infrastructure, and then the bottom part are the endpoints that attach to an LTE network. And so I might actually start on the bottom, just describe the endpoints and kind of work my way up. So in our case, I mentioned we have the three segments: fixed locations, vehicles, and IoT machines. And so these are examples of the routers that we supply that leverage LTE. In our case, we have the ability to have multiple modems. And so you can have a private LTE SIM. So you get a SIM provider, a SIM for your private LTE network. And you can use that in conjunction with a public LTE SIM as well in the second mode. So why would you use that? You might have a security vehicle at a stadium where you do want to leverage that private LTE network and show video while you're there. But when you're off premise, you can flip over to the public network. And then we connect over, CBRS, which is the 3.5 gigahertz, to infrastructure providers. And there's a variety of companies that provide small cells or access points and the core network, et cetera. But then because we're talking about deploying an enterprise, you need enterprise grade management. This is really the differentiator of our solution. Up on the left is NetCloud Manager, which we use to describe it. And then usually when you have an infrastructure provider, they have their own cloud-based management for managing the infrastructure. So this is a quick overview of how the solution comes together for private LTE.
Okay, great. So John, diving a little bit deeper here, because you can talk about some of those things and go down a level, and also that connectivity into the macro network that Ken mentioned. John, you're muted again.
Yeah, my apologies. I think it's important first to understand the data flows, right? So, private LTE network is all about connecting devices to applications, either user applications like voice and internet or IoT applications. So let's think about the different ways that data kind of traverses this network. First off, you've got some data that might have to stay local, and it might have to stay local for a number of reasons, but latency or privacy might be two of those. So the data is going to end up going through a local breakout or local gateway and stay in on-prem, some sort of a MEC storage environment, such that Pivot would provide as an example. Then there's also data that really doesn't need to stay local, and this then ends up having to go to either an enterprise, private, or public cloud. In that case, you're going to end up having to traverse into a cloud gateway, an SRP gateway, and that's going to then traverse back to the enterprise, public, or private cloud. Now that data has to actually transfer has to happen both within the customer prem, so if you have a device on-prem, or if you have a device off that customer premise, because these island networks are going to be few and far between. Most devices really need access wherever they are. So that means you have to access that public MNO network or perhaps another private LTE network. Still need to get that data back to its application, right? So it's going to have to flow through some sort of an IPX connection. Cineverse has our own IPX that we provide, again, in the public domain. We're making it private. And then it ultimately has to get back to that enterprise public or private cloud. So it has to go through, again, that cloud gateway.
Okay, and just so we're clear, I showed a picture of a metro area, but these private networks that we're connecting could be across the country or across the world, right? So you could be a distributor, you could be an auto manufacturer, and having the networks each connected, as well as people having access wherever they are, right?
Right. You can think about it in terms of like a local delivery truck, right? Where that truck leaves your warehouse, it goes around, makes its round of deliveries within that metro area. You're really looking at creating a very tight relationship with a local MNO in that relationship. Or you could be looking at a global supply chain where you're going from one private network onto a public network, across the ocean into another private network in another part of the world. And you have to make sure that all three of those networks are connected seamlessly. And that fortunately is provided for in terms of a mechanism in the roaming infrastructure we've already got in place with the public networks.
Okay, great. All right, so Gary, from the Pivot point of view, let's bring some edge compute into this, some edge connectivity. So how does that fit within the network here?
So yeah, we simplify the view of what edge compute can do and the functions that are enabled through edge compute into three principal pillars or areas represented here on the left. So one is simply an edge application environment. So a lot of the discussion around why edge compute brings value is centered around, the reality that most companies over the better part of the last decade have moved immense numbers of applications and immense amounts of data out of the conventional data center environment and to remote or into the cloud or public cloud environment. And so that's been fantastic. It's been monumental for the industry. It's delivered tremendous economic value, but it comes with trade-offs. And one of those is that some mission critical applications that really demand lower latency have to accept a latency that isn't quite as optimal. And the same is true of security. So in the case of some data sets that are in public clouds, I think the reality is that most IT managers know, most CIOs know, some of that data probably should exist and reside behind their firewalls. So companies are beginning to selectively repatriate applications back to the edge. So that's a big part of the practice that we run there. Edge networking, functions like SD-WAN is another one. So pushing that kind of functionality out of the conventional data center networking environment and all the way to the edge to the remote office, branch office kind of location, fast food stores, fast food restaurants, convenience stores, retail store environments that are non-conventional IT environments. So it gives them the ability to enjoy the benefits of SD-WAN, lower complexity, lower cost. So that's another big piece. But the one, of course, that is really relevant to the discussion here is edge connectivity. And so that's where our private LTE solution play lives. It is where we, bring not only edge compute as a foundational element, but then on top of that, the MEC software stack to enable, the fusion of communications and IT environments in a way that brings a lot of security to the applications and data that's sitting on that edge device. So that's sort of the way we view the role of edge compute. It provides a foundational piece, a physical platform for applications and data to reside very, very close to where the data is being created and or where the data is being consumed. And that's tremendously important, particularly as you look at cases like IIoT, maybe in the industrial environment where super low latency, closed loop analytics, predictive maintenance, those kinds of things really demand that application functionality sit very, very close and deliver really low latency.
Right. I think when we mention low latency, I'm laughing here already, is, everybody jumps immediately to remote surgery, and you and I have had this discussion, but in reality, that's quite a ways away. But the real function is things like security cameras, as you're saying, manufacturing automation and control, where you've got either a lot of data or things that need processing very quickly, put it local, action it there without going up to a cloud or adding the latency in that connection, right?
Indeed, indeed. And I think you should try remote surgery and let me know how it goes.
Well, that's always my joke is, who wants to be first? And nobody ever puts their hands up. So, okay, so good. So we've got a kind of picture here of how things look. I want to introduce the discussion here. We have to talk about CBRS. CBRS is the 3.5 gigahertz band in the US. It is now, as of January, it is now open. We actually have the general access, the GAA down there, and there's 150 megahertz that you can basically use. It's called lightly licensed, it's shared spectrum, but basically you can buy a device, use this without a license. There is also, if you look in the middle, there's the PAL, which is the priority access. There's another 70 megahertz there. Those auctions are actually going to happen in July or start in July of this year. And that gives an enterprise an opportunity to buy a license for a given county and then always guarantee that they've got access to that band. Now, CBRS is a US phenomenon. I know we have some international folks on as well. There is talk of this in other countries as well, but it really has opened up the opportunities here for enterprises to really build their own network without the involvement of an operator on premises. As John was saying, you may want that connection to the operator for going outside the premises if you're a delivery truck or something like this. But the CBRS is here. You can buy equipment today, and it makes life a little more interesting for us. So I'm going to hand back to you, Ken. And the title on this is what is private LTE, but really talking about the licensed spectrum, the shared spectrum, or the unlicensed. We get this question a lot: is what should I use? Which one is best? So you want to spend a few minutes talking about views on which one, right?
Yeah, you set some good context for CBRS, which is really a shared spectrum. It's owned by the department in the US. It's owned by the Department of Defense. It's really only used to land jets on aircraft carriers. Not here in Idaho, not in Omaha, et cetera, for the most part. But it's really, that's just one type of private LTE. We have private LTE customers, for years. If you look on the left side, you have licensed spectrum. So if you're a mine in the middle of Nevada, you might go to one of the wireless carriers and say, hey, look, there are no towers near my mine. I'd like to license your spectrum to use it in that mine. Or I might go to one of those mobile operators who owns that spectrum, and I might say, hey, can you come in and set up a private network for me and operate it as a managed service? So that's the licensed spectrum. There's some work on the unlicensed spectrum on the right side to run LTE in unlicensed spectrum in the same place that Wi-Fi is there. So in the 5 gigahertz range. There's some pros and cons on that, but one of the issues you have there is the underlying spectrum, because it's unlicensed, it's being used by Wi-Fi, baby monitors, HDMI extenders. So it's rough spec. It's like having a Ferrari on a dirt bumpy road. You're kind of limited in how fast you can go based on that spectrum. So the shared spectrum, I think, is really interesting. And obviously we're starting with 3.5, but there are other spectrum in the US that we're looking at, and spectrum throughout the world, which is why the CBRS Alliance is an international alliance to look at that. So in terms of what you're choosing, it really depends on what your use case is, how dense an area is. I ran CBRS at my house, here at my house, all of last year under a special license, a temporary license. Everything in my house went through it. I just wanted to see how reliable it was. Netflix, all my IP cameras, my Wi-Fi, Windows upgrades, and it was phenomenal. So for me, it worked great here at my house.
Right. So actually, we've had some questions come in. I think one of these is a good one to answer now. Is what's the coverage range of LTE using CBRS? So could you use it for a utility application, for example? Or what are the options? You mentioned indoors, obviously, but I think there's different classifications. So how broad, how far can we go with CBRS?
Yeah, so think indoor and outdoor. So outdoor, I think the generally accepted rule is about 1 kilometer, but we worked with a shipping port on the West Coast doing a POC where we put up a small cell and our engineer drove away with a Cradlepoint router and had connectivity 1.5 miles away.
Wow.
So in the outside, there's good range. Inside, the frequency really doesn't penetrate buildings, which actually is a really good thing. So if you're inside of a warehouse or a factory, you can use it inside the factory knowing that you're not going to interfere with anyone outside. And for the most part, your walls are going to prevent people outside from interfering inside. So in general, I would say about 1 kilometer, which is 0.6 miles, is a good rule of thumb. But all the infrastructure equipment, there's a lot of different categories, a lot of different designs. And I would say it can go up to 1.5 miles. The FCC kept the power levels low, by the way, so that you could have multiple users in a metro environment without having them step all over each other.
Right. Great, good. Okay, so John, so where does CBRS fit into your bigger picture here? And how do we bring it all together?
Sure. So, one of the cool things about private LTE is it's based on LTE, right? And LTE has been around for well over a decade. It's got a great ecosystem that's grown up around it. There's standards bodies around it. So there's a lot of support for pretty much anything you want to do in a private space. It all starts with the device though, right? That device has to have a SIM. That SIM identifies the device. It connects it to that core network that you provide in the private LTE scenario. It also homes the device. So when you go off-prem and you go into a public MNO, that MNO essentially treats that device as a visited device from any other network provider. It provides connectivity in accordance with any agreements you may have with that MNO. And then when that device goes back onto the premise, it reattaches to the private LTE device. So there are some variations on that may be a little bit more problematic, but I think it's really important to keep in mind that device has to be associated with that home network.
Okay, so again, we've had a couple of questions here. There's one on SIM cards, I think it's a good one to address right now. So firstly, can you use the smart SIM that can roam between public networks and private networks? I think the answer is yes. But also, is an eSIM option planned as well?
Yeah, I mean, I think both of those are certainly relevant, and we're going down the direction of eSIMs as well. I think you do need to be a little careful with smart SIMs that may not be home to the network. That networks want to hold on to a device, right? And so if you take a device from one network to another, you need to have a pretty good mechanism by which that device recognizes the preferred network, and that can be a little bit problematic in a private LTE scenario.
Okay, good. All right, so Gary, you kind of did the bigger picture of the edge. Let's dive down a little bit here, start talking a little bit more about the applications and how it all fits together here. You see we're connecting through to the MEC and then into LTE and the devices.
Yeah, so we've talked a lot about basic concepts of LTE, about the benefits, types of use cases enabled. But undoubtedly, there are people in the audience listening who are thinking to themselves, what does this actually look like in deployment? I can get my head around this better if I could see it visually. That's really what this architecture slide is designed to do, is so you can see the various elements and how they interface to one another. So, it starts with obviously outside connectivity to the internet, to cloud storage. But that, we talked about edge compute as a fundamental component of the architecture. And I addressed, the fact that there's application content there potentially. There is data there, sensitive data, There are applications that require that low latency that a private LTE localized network can deliver. But there's another really critical piece that's enabled by that edge compute hyperconverged resource, and that is to host the elements of the all packet core, the wireless network core that provides the intelligence that enables LTE. And there are two functions principally of that EPC core definition that ideally should reside on that local server, a local resource, and those are the S gateway and the P gateway. So most implementations, if they don't have the entire core resident at the edge, at minimum have those two functions because they require really, really low latency to deliver the kind of performance that people expect from LTE connections to keep those at the edge resource. So you're going to have not only the MEC stack that we talked about providing the security, local breakout, and other fundamental functions of multi-access edge compute, but also that EPC core functionality at minimum S&P gateway. And then from there, that's going to connect either directly by Cat5 wired connection or using a Cradlepoint modem, going to connect to access points from companies like Ruckus, like Spider Cloud, like JMA Wireless. So in deployment, those devices, and you can tell even by their appearance, that looks very much, physically speaking, like a Wi-Fi deployment. So you could have dual LTE and Wi-Fi connectivity, again, hosted back to that edge resource, and then a mix of devices connected to that, either from a consumer and or enterprise perspective, back of house applications and devices that your employees use in your factory, in your distribution center warehouse, or in your retail store, cameras, et cetera, handheld scanners, as you can see there, or from a consumer perspective, again, as we talked about, John was just addressing the ubiquity of what Cineverse enables to allow devices and or subscribers roaming into and out of a private LTE environment, into a macrocellular environment. So it's all of those things. And it also, very importantly, at the bottom of the picture here, you can see that we make reference to a future path to 5G. And I think that's going to be addressed in greater depth on subsequent webinars that you're hosting, Ian. But it's important to note here that once this architecture is in place and you have edge nodes deployed and you've got a local infrastructure in place, that in most cases, that is going to be a software overlay that provides a very direct path to 5G evolution of your network, which is an exciting aspect of this as well. So this gives you a general idea. You'll also see that there's some cloud-based core functions. Most companies are hosting the heavier weight database-driven functions like HSS, the MME, are going to be up in that Evolve packet core that's going to be cloud-based. And then we provide some cloud-based management capabilities so that if you have 500 of these edge devices operating these localized private LTE networks, that you can have visibility and management and span of control to managing all of those on a touchless basis through a cloud-based portal. So this gives you a general idea of what that deployment looks like.
Right. So, and actually, I was going to draw attention to the text at the bottom there. It's really important to realize that as an enterprise, you don't have to go and buy your own EPC. You don't have to be AT&T or Verizon or T-Mobile or Vodafone who have their own. You can actually get it hosted in the cloud. I think John, Cindy, you're going to touch on this in a minute. But again, some functions do want to be local. There's actually a question here, which is probably a good one here. Is it possible to deploy private LTE in Africa? And so if we just look at this picture, then obviously the access points could be in Africa, but the edge compute could be in Africa, right, local. But then as long as you've got a connection to the cloud for the hosting, then I assume that EPC function can sit anywhere, right? Anybody want to take that one?
Yeah, I mean, we have regional deployments of our cloud EPC. We follow the model that Gary discussed here. There are certainly benefits to having an EPC.
Yes.
But that said, you can have it anywhere. We can provide service to Africa from Europe. We can provide service to Australia from Asia. You can be out in the woods, so long as you've got that broadband connection and a local breakout, you're fine.
Yep. I think, Gary, you were going to say to me, you were muted there.
You're still muted.
Yeah, so the question comes up a lot. I mean, even for those of us that do business in North America, the natural question about availability of this kind of thing in Canada comes up frequently. There's a step behind the US in enabling the shared spectrum model. So it is fundamentally that access to shared spectrum that makes all this possible. Doesn't mean that you can't create a private LTE environment using licensed spectrum by agreement with and the involvement of a local mobile network operator who's an incumbent provider in that geographic area. But in terms of the way we're depicting it here, and a network over which an enterprise has full control and over which you're not going to pay a metered monthly recurring charge on every connection, that type of private LTE architecture can only be enabled where there is shared spectrum available from the local authorities. And we have the luxury of that in the US. Not aware that we have that yet in Africa, but I'm sure it will come someday.
Yeah,
Okay.
I will point out, just to follow on, I know that the scene is changing internationally. It's very dynamic, and there are some, different governments are opening up, like Band 42 in Germany, Band 43 in the UK, Band 42 in Australia, et cetera. So it just really depends on what spectrum is available in that area for people to be able to run their private LTE networks.
Okay, good. Okay, so actually, Ken, I'm going to go back to you. A couple of use cases here, and I said we weren't going to dive into this in great detail, but you've got a good slide here with some different examples. Maybe just talk about a few of these. And actually, as you go through this, we did have a couple of questions for farmers. Can we deploy this for farming and mining? Options there, or what can we do here?
Yes and yes, but generally the theme for when you would choose to use a private LTE network, what we're seeing for this is when you want to create a wide area LAN. So we all have private networks at our homes. They still connect to the internet, but they're private because we control what devices go on there, et cetera. And so really, in a warehouse, people have really struggled with Wi-Fi inside of a warehouse, meshed Wi-Fi, because there's it's a contention-based protocol. It's like British Parliament. Everyone talks at the same time, trying to get control of the conversation, and the last person standing gets to go. Whereas LTE has some efficiencies. It's a scheduled protocol. It has less interference. It's a little bit more reliable. You think about an amusement park, you could light up that whole thing. And every use case I described in my intro, whether it's retail stores or branch offices or security vehicles or employee buses or security cameras, you can have all those endpoints within that park as your own. You're creating a wide area local network that's still backhauled to the internet, but you have a lot more control over what devices. And in that case, again, there's a lot of great advantages for Wi-Fi in certain use cases, but meshed Wi-Fi covering a large area has had some challenges. So anyway, that's the theme across this. You asked about mining, and the other one was
farming.
Yeah, so I've been on the phone. I had in Central California, someone that wanted to set up private LTE, and the plan is set up a small cell in the middle of the operation, and then have private LTE on the vehicles and on the irrigation system to be able to communicate. It's your own private network. Private LTE has a longer range typically than Wi-Fi. And mining is the exact same thing. We've got several customers that are currently in deployment on that. But anyway, that's the theme of when you would want to consider using a private LTE network.
Okay, great. Okay, so one thing we haven't talked about is we've talked about building it, Gary. We haven't talked about the whole process here, how we design it, deploy it, and we've got to manage this thing as well. So can you walk us through really the life cycle here of what it takes to build and run a network?
Yeah, and I'll try to do this in a generic fashion so that it doesn't come off as at least completely as a commercial for Pivot. But we think it's a sensible model for anybody who's looking at, what are the stages of this process and what does it really take to, fully get your arms around a wide scale deployment in particular. So we talk a lot about, for us, kind of a target market profile is this robo profile of customer, right? The remote office, branch office, endpoint that doesn't have any IT infrastructure. It's got no data center environment of any kind. It may have a small rack or in a wiring closet or a back room, but that's it. So, that's a complex environment to go put hyper-converged edge compute resources in and deploy radio gear in. And how do I do that if it's 1,500 locations or more. So we look at that as it's a life cycle. A deployment is really defined by stages of a life cycle of the deployment. So it starts with us walking in partnership with companies like Cineverse, like Cradlepoint, like our RF infrastructure partners, and consulting with the customer and really designing that architecture. So it's a build, consult, design up front. We then, from a Pivot perspective, one of the competencies that we bring is a large-scale factory integration capability, which is actually what you see depicted in the photo in the backdrop of this diagram, of this graphic. So it's a scaled capability to take a custom kit, build that with all the disparate parts of the solution as we just viewed them in the deployment architecture slide, and really build a custom kit, even to the extent of burning in custom software imaging, and then kitting that and packaging that to be distributed out and shipped out to potentially hundreds, even thousands of locations. So that ability to build, integrate those various parts, to test and certify that is a holistic solution, and then package and deliver and deploy that at the other end. So, you know, I talked up front in the call in the webinar about our network of field resources. You need people at every endpoint there to then receive that, unkit it. This isn't something that an end user customer is simply going to be able to unpackage and activate. So you do need a deployment capability there at the other end. And then in terms of day 2 support, break fix support, and managed services, you know, you need to support that centrally. And you may also need the ability to manage that from both a network monitoring standpoint as well as a security monitoring standpoint if it's a far-flung deployment. So we view all that as the life cycle of capabilities built around that center blue dot, which is the fundamental technology that enables all this. So that's an important piece of this, an important consideration for everybody listening.
Okay, so we have another question here. You touched on this already, but which companies do you guys work with providing the RAN, radio access network?
For my part, I'll go first. I will tell you that we work closely with both Ruckus Wireless, which is now part of CommScope, of course, as well as Spider Cloud. But we'll work with any of those vendors. JMA is another very capable vendor in that space, and we're open to working with all of them, but we've done the most work with Ruckus and Spider Cloud.
Okay.
Ian, yeah, I just wanted to weigh in. I just want to amplify what Gary said. It is a key part of Cradlepoint's strategy to have competent partners like Pivot that can be the trusted advisor to an end customer and can pull the whole thing together. Do that because you need the expertise, you need the experience, certified installers, etc. And I think the customers want someone that can pull together endpoints like what we provide at Cradlepoint and combine it with the infrastructure and be one-stop shopping, and in some cases be the managed service provider. So I think that's a really important role to have in the ecosystem.
Right. Yeah. At the end of the day, we're building a network for a purpose, right? I mean, you know, Ken built a CBRS network just to see if he could in his house, but generally speaking, you need to facilitate a use case that's driving value to the enterprise, and that requires a really robust partner ecosystem that brings the intimate knowledge of the industry and the customer, along with all the technical knowledge to make sure it happens.
Right. You know, I kind of think this is like graduating high school, right? You need an English teacher and a math teacher and a physics teacher and biology. And like, you can't get through just having one English teacher. You can't get through this just with a RAN. You can't get through this just with edge compute. You need all the pieces, right?
You need a counselor to kind of coordinate all that to meet the students' needs, right?
You need a counselor. Okay.
I like it.
That's good. Okay, so John, you get the last slide, and we'll open up for just a couple of questions here. I normally encourage people to send in questions. We've had loads. So how do we go from where we are? We've talked about private LTE. You said it's been around for 10 years. I call it long-term employment. How do we get, you know, somebody's putting in, let's say, private LTE today, you know, in Africa or in that mine we were talking about. Are they putting in something that's stuck in LTE, or is there a migration path through to 5G? Can we move forward there?
Right. So first off, you know, let me caveat, I'm a huge proponent of 5G. It's been a focus of my career for at least 5 years now. Right now we're certainly deploying LTE networks, and the core itself is cloud-based, so there's a pretty good upgrade path on the core. The RAN and the devices are going to be a little bit trickier. Let's talk about the RAN first, because that's invested in in-place capital. If your plan is to ultimately go to 5G, you need to be having conversations with your RAN vendor to make sure they've got a good path to 5G. Preferably, it's a software path, but right now that's basically means you've got to buy a really expensive RAN device. So there is that trade-off there. But we are going to see the step from LTE to first off 5G non-standalone, where you've got the 5G radio and the eNodeB operating together. That still relies on the traditional EPC, so that's a radio focused upgrade. And then ultimately you'll go to that full 5G system where you've got a 5G core, you've got a 5G radio, they connect to each other. I suspect in most deployments, you're still going to have a lot of legacy LTE equipment, because you're not going to just swap out devices when you jump to that next technology. So you're still going to have to make sure you've got an interworking capability between the 5G network you're deploying and the LTE network that you're deploying. Just kind of one more comment, the 5G core, that's where network slicing takes off, right? That's where you've got the ability to break down and reassemble your core and your radio in really unique ways. And I'm really excited to see what enterprises do in this space. There are going to be tens of thousands of sandboxes all over the world. And I think the way they assemble these network slices is going to be really amazing.
Yep. So Cineverse, you guys host an EPC for your clients, right? For private network.
Right.
I assume you'll host a 5G core as well. Yes?
Certainly, we've got plans to take that 4G capability and walk our customers all the way through that non-standalone into that full standalone. We've also got intentions to create an IPX, that connectivity between networks, create a capability there to connect that slice in one network to a slice in another. So you've got that seamless experience regardless of whether or not you're on-prem or off.
Okay. All right. Great. So we do have time for a few questions. We had lots come in, and I've been trying to address a few of them as we go through. If we don't get to your question, I will make sure you get an answer. Some of them are specific to the vendors here, but so I'll forward them on to them. But others, I'll just shoot you an email for the audience members who we don't get to. One question we have to start with that was in all the questions we got in ahead of time, probably the most common was how do Wi-Fi and LTE or private LTE coexist? What's the differences between them and things like this? I think a lot of people see this as an either or. I'm pulling this slide up, so it's got the Wi-Fi logo on it. But I think there really is a coexistence. So I don't know who wants to go first. Whoever puts their hands up first. Gary? Okay, Ken, you go. Yeah.
Yeah, I would say our first field testing of private LTE was at Texas Motor Speedway, working with an infrastructure provider. And they rented 3 NASCAR drivers and 3 NASCARs and ran private LTE. They had tried Wi-Fi and it worked great during the middle of the week, but on race day, it didn't work so much. And so, there's, what's the better technology is a good question, but also keep in mind, it's the frequencies, it's the spectrum that you're using. Having different spectrum makes all the difference, because people are showing up with their smartphones that have Wi-Fi and it just destroys that spectrum. So I think you're going to see a lot of companies that use private LTE to provide operational networks, connecting the concession stands at a stadium or a NASCAR on game day, because it doesn't compete with all the Wi-Fi that's being brought in there. So I think that's one of the coexistence issues.
Okay, Gary?
Yeah, I think this is a really important point to cover, because I can tell you that prior to coming to Pivot, I was with a large company in the technology space who had a considerable Wi-Fi product offering in practice. And there was contention even inside of the company about exactly how to position this kind of stuff relative to and juxtaposed to Wi-Fi. And I think the overriding concern is, and I suspect there probably are a few people in the audience today who are saying, looking at the advantages that we're suggesting that private LTE has over Wi-Fi, and it does have some, undoubtedly, but saying to themselves, you know, I just approved a PO that had a lot of zeros on it for a Wi-Fi 6 upgrade. What are you telling me regarding private LTE? How would I possibly go ask for budget for, you know, yet a better wireless technology than what I just invested a bunch of money in? And the answer is it's not a forklift. It's not an either or discussion. It is a discussion of harmonization. Private LTE augments Wi-Fi. And, you know, the gap between Wi-Fi and private LTE, when you talk about things like reliability and performance and security, it certainly closed with the introduction of Wi-Fi 6 to a great extent. So Wi-Fi is getting better all the time, but there are those fundamental advantages in terms of the network density that you have to build with Wi-Fi to get the same coverage and performance of an LTE network, the security that is inherently part of LTE that isn't comparatively as good with Wi-Fi, even though it's getting better. You know, and with that density of network comes additional cost. So for a wireless signal that's got to, you know, navigate around thick concrete walls or into subterranean areas, you know, getting Wi-Fi around those physical barriers creates more network density and therefore more cost, more complexity to support. And then, of course, the security question. So yes, there are differences, but we position it as, you know, one fundamental advantage Wi-Fi will continue to have for the near term and for quite a while over private LTE and CBRS is the availability of devices. The ecosystem of Wi-Fi devices is infinitely larger with Wi-Fi. So as you look at this diagram and you look at the, you know, the kinds of devices that consumers are going to walk in with, only a fraction of those today are going to support CBRS. You're talking Apple iPhone 11, the newest Samsung models. Whereas, you know, particularly from an IoT perspective or consumer devices, there is an ocean of devices that are supported by Wi-Fi. So it is about augmentation, harmonization, and not an either or.
Okay, great. So, John, I'm going to let you have the last questions. We do have to wrap up here in a minute or so. And this is one that came through. What is the cost of connectivity through the wireless carriers? So if I've got my private LTE network, and if I go back to one of your pictures here, if I want to connect through that private network into the operator network there, how, I'm not expecting you to tell me the price, I know it varies, but how do they price it? Is it usage-based or how does it work?
Yeah, you know, unfortunately, there's really no clean answer here because we are breaking new ground. And in fact, actually, in some respects, we're addressing old ground. Remember back in the 90s, for those of us who had cell phones back then and were actually using them, you know, if you went down the street, you may actually start roaming on a different network. And we all had to have a commercial model that made that happen. Private LTE kind of brings that back a little bit, right? Because you do have to have local coverage. You have to have a local partner. You know, we're driving with MNOs in the U.S. specifically to try to create some sort of a revenue sharing model so that coverage can be, you know, seamless. It can be economic as well. But that's just kind of on the handset basis. The other dimension you have is IoT, right? IoT devices can run the range of really, you know, bandwidth hog applications, AR, VR type things, AGVs, sorry, automated guided vehicles, or they can be just, you know, really low load but high control devices like a location sensor. And the market still hasn't figured out yet how to take those low power devices and make them roam cost effectively. We're making progress. We've got better rating models that are in place, but you know, the MNOs are still trying to figure out how to actually make that work, and that has to come before even the private networks can interact with the MNOs.
Great. Okay, so we are out of time. I'm going to zip back here to my speaker slide. I want to thank Ken, Gary, and John for your time today. This has been great. We've got a lot of questions. We'll get those answered. For the audience, we are recording it today. We'll send out an email with the recording details and also with the slides. If you have any follow-up questions, please let us know. And also, we'll have details of the next 3 webinars in this series. So, gentlemen, thanks very much.
Thank you.
Okay, thank you.
Thanks, Ian. Thanks, guys.